students, I welcome you all in my YouTube channel Physics World. Now in this video you will find that what is point charge, what is continuous charge distribution and line charge distribution, surface charge distribution, volume charge distribution, and also what is linear charge density, surface charge density and volume charge density. In this video you will also find that what is electric field, what is electric field strength, electric field lines of forces and superposition principle. So let us come to our first topic, point charge. What is point charge? Any charge which covers a space with its dimension much less than its distance from an observation point. Suppose that this is the observation point from where you are observing this charge, whose size is very small in comparison to this distance. So this charge is treated as point charge in this case. Now come to the next topic, continuous charge distribution. A system of closely spaced charges is known as continuous charge distribution. So continuous charge distributions are three types. First, line charge distribution, surface charge distribution and volume charge distribution. Now come to the point, line charge distribution. If the distribution of closely charges are found over a line or a circumference of a circle or over the edges of a cuboid, etc., then such type of distribution is known as line charge distribution. And line charge distribution has a density, the charge per unit length. The charge per unit length is known as line charge distribution. Suppose that we have a line whose length is L and the total charge present on this line is Q. Then the line charge lambda will expressed as Q by L. Also, if the small distance dl contains a small charge dq, then this linear charge density lambda can also be expressed as dq by dl. From here, the unit of the linear charge density lambda is coulomb per meter. Coulomb per meter. From here, if we want to find out the total charge on length or line, then Q can be expressed as integration of line integration of lambda dot dl. Now come to the point, surface charge distribution. If the closely charges distributed over a surface, then the distribution is known as surface charge distribution. And the total charge per unit surface area is known as surface charge density. It is represented by letter sigma. So if we have a small area A and the total charge present on that area is Q, so the surface charge density sigma will expressed as Q upon A. If we take a small area element dA and the total charge present on this small area element is dq, then the sigma will also expressed as dq by dA. Now the unit of surface charge density sigma will be coulomb per meter square, coulomb per meter square, and by the formula of the surface charge density we can find out the total charge distributed on the surface will expressed as q equal to area integration sigma dot dA. Now the volume charge distribution. If the distribution of charges are found over a volume, so such type of distribution is known as volume charge distribution, and the charge per unit volume is known as volume charge density. It can be expressed by the symbol rho. So suppose that we have a volume element whose total volume is V and the total charge distributed over this volume is Q. So the volume charge density rho can be expressed as Q by V. If we take very small volume dV and the charge distributed over this small volume is dq, then this rho can also be expressed as dq by dV. Now the unit of volume charge density will be coulomb per meter cube, and the total charge distributed over the volume can be expressed by the volume integration of rho dot dV. Now this is all about the distribution of charges. Now come to the point electric field. Electric field, the space around any charge in which another charge can experience an electrostatic force, then that space is known as electric field.